Hey guys, this is Carrie, and in this video we're going to be taking a look at simplifying simplifying higher roots. They're not just square roots this time. Alright, so we did the do now problems, but looking ahead to the lesson problems, actually this lesson problem was for you to do. So hopefully you were able to do that before you jumped into this segment of the lesson. The one that we're going to be reviewing in this video, though, is lesson problems 2 and 3. Sorry. So simplify the expression. Ooh, cube root this time. Cool. All right, so cube root of that. All right, so with the ones before, even when they were negatives, we were kind of just taking a guess and sort of simplifying them that way. But with this one, with all these variables and this big number 250, I think we're going to have to jailbreak. So let's use our jailbreak method and see if we can come up with any ideas about these. All right. So cube root of this. All right, well, the first thing I'm going to do is I need to break down the 250. So for the 250, that is, it's an even number. It's also actually, oh, this is a nice way. It's a multiple of 10 because it ends in 0. So it'll be 10 times 25. Breaking down each of those a little further, 5 times 2 is 10, and 5 times 5 is 25. None of these numbers, 5 nor 2, can be broken down any further. So we have 5 times 5 times 5 times 2. All right, now looking at our x's here, x to the 6th power, that's going to be x times x times x times x times x times x. And you know what, I'll actually write the y's out this time, but maybe we'll even come up with a shortcut in just this one problem. I don't know. So y, 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 y. Cool, I think I've got 14. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Great. All right, so we need to simplify this expression. Well, the great part about cube roots is the groups are going to be trying to escape in groups of 3 this time. So we've got 3 5s. They try to escape, and this is a harder jail. The higher the number, the harder the jail, right? So only one ever gets out, no matter what the group size. And the rest die. So 1 5 escapes. Now from the x's, we're getting to make groups of 3. So we have got a group of 3 here, and a group of 3 here. Well, that makes sense. 2 groups of 3 does give us 6. So this is going to be, okay, well, 1x from each of those groups escapes. The rest die. So we have x, but 2 of them out. So x times x is x squared. Now for the y's, this is one of the reasons why I wasn't sure if I wanted to write it out. We're trying to make groups of 3, right? So if we had one group of 3, well, that's just going to give us 3 y's. Not enough. We certainly have 2 groups of 3. That gives us 6 y's. But we have 14 y's, so we can do more groups. If we had 3 groups of 3, that would be 9 total. Okay, so we can definitely do that. Maybe 4 groups of 3? And that gives us 12 total. And that's really close to 14, actually. It falls a little short of 14, but it would be impossible for us to make 5 groups. So it looks like what we're going to have here is we're going to have 4 groups, because 3 times 4 is 12, with 2 leftovers, because we needed to have the extra plus 2 in order to make the 14. And those 2 leftovers are here. All right, so with 4 groups, let's see, 1 y from each group escapes. 1, 2, 3, 4 y's escape, 1 from each group. And let's see what we're left with. So now we've got our fancy cubed root jail. And I left an extra space here. It's really multiplication, and I'm just doing that visually to show, to show that the cubed root is part of the jail here. And we have a 2 left inside, and no x's, and then y squared. Yeah, made it a little bit too large, but that's okay. We'll fix it in post-production, or we'll just box our answer like that. All right, so here we go. That is completely done. For problem number 3, we can take some clever reasoning and apply it to this one as well, and we start to notice some patterns. Well, before we can do anything clever, we do have a fourth root though. So we're going to be breaking our numbers down into groups of 4 this time. So 64, that's 8 times 8, 8, 2 times 4, 2 times 2, 2 times 4, 2 times 2. So we have the fourth root of too many 2's. Too many. Is that 6? 1, 2, 3, 4, 5, 6. Yep. Cool, got it. Oh my god, I do not want to write x to the 21st down. So we're not going to. We're going to think about this logically. So breaking down those 2's, this time we're trying to escape in groups of 4. We see one group of 4 here. No matter the group size, whenever they try to escape, only one gets out, the rest die. So we have a 2 outside. Now thinking about these x's, we actually can be really clever and not even write them out. If we wrote out 21 x's, we're wondering how many groups of 4 we can make. All right, well, let's see. 4 times, we're thinking about multiples here. 4 times 5 gets us really close to 21. 4 times 5 is 20 x's. So we could have 5 groups of 4, because that's going to be 5 groups. Oops, let me put that down here. 5 groups with 4 each in them. So that would be 5 groups with 4 each. So that would be 20 of them. But to get to 21, we'd have 1 left over. So there we go. Now because we have 5 groups, 1 from each of those groups is going to escape. So 5 will escape, and the rest die. But we do have a leftover that we have to remember we had. All right, now here we've got y to the 45th power. So how many groups of 4 can we make with that? And we want groups of 4 because this was a 4th root. How many groups of 4 can we make with that? Well, we can certainly make 10. If we had 10 groups, that'd be 4 times 10 is 40. Can we make an 11th group? I think we can. Let's try it. 11 groups of 4. So we have 11 times 4, because there's 4 y's in each group. So that would account for 44 of our y's, which is super close to 45. We have 1 left over. So 11 times 4 gets us to 44. To get to 45, we need the 1 left over. All right, so with 11 groups of 4 y's, 11 y's will escape, 1 from each group. So you get y to the 11th. And then over here, we've got a 4th root of, let's see, we had 2 2's left inside from our work before, 4. 2 times 2 is 4. Now here, we had 1 x left over, so that'll be an x. And we had 1 y left over, so that will be a y. Sorry that I keep drawing my boxes like that with the square roots outside. It's just I drew my square roots way too large. So this is a nice little pattern, and hopefully you can find these groupings. Now let's say that you have a hard time seeing these groupings. I personally don't really like to use the calculator. I don't know why. Sometimes maybe it's just laziness to get it out. But let's say you get stuck on a problem. Like I'd rather be able to answer that problem than get stuck on it. So let's say we're trying to figure out this one, and we didn't really see it right away. How many groups of 4 can we make with 45 y's? So let's say you didn't see 11 right away. Well, what you could do is what we're trying to do here is with how many groups of 4, we're trying to split those 45 y's up. We're trying to divide those 45 y's into groups of 4. So if you pop over to your Desmos calculator, you could take all 45 y's and divide them into groups of 4. What this says to me is we can make 11 full groups. We are not worried about having a decimal number groups. So what we can do down here is we can say, okay, well, we made 11 full groups from this number here times 4. Oh, well, that gets us to 44. And then we had 1 left over. So this gives us 11. And then thinking about 4 times 11, 44. Okay, to get to 45, we have 1 left over. All right, so this is another way to think about these problems if you find yourself getting stuck coming up with the stuff for the grouping numbers. All right, this pattern is much more evident as soon as you start practicing it, so I hope you guys enjoy seeing this pattern in action as you simplify these next couple. Oh, and there's some interesting stuff here at the end. Cool. Well, we'll see how we do with that. This is a really cool problem set. All right, good luck, and we'll continue to work on this together. Bye.